Hi everyone, so here we are on chapter 22. We are actually going to combine chapter 22 and 23 together because they are related to the same concepts. But first, we're going to start with redox reactions. But in order to do redox reactions, we have to first know how to assign what we call oxidation states, okay? So there are a list of, I think, approximately 6 rules. So we're going to go over all of these rules so that you know how to assign oxidation numbers. Now, this is a very important skill. This is like the foundation for redox reactions. You have to know how to assign their oxidation states before we can even identify if it is a redox reaction, okay? So this is very important in terms of knowing how to do this. All right, so here we go. Rule number 1. The oxidation number of monatomic ion is equal in magnitude and sign to its ionic charge. So here are some examples. Okay, so if a charge is already listed on it, then the oxidation state will just equal that charge. Okay, so you can see here that these already have charges on them. So then their oxidation states are going to be those same numbers, okay? All right, then let's go to rule number 2. So let's scroll this up a little bit. Okay, so rule number 2, the oxidation number of hydrogen, so this is regarding hydrogen, in a compound is always +1 except in metal hydrides. So a metal hydride is an example that I have here. When you see hydrogen listed second, then hydrogen will take on a -1 charge instead, okay? But typically hydrogen is going to be +1, okay? So the rule is hydrogen is +1 except if it's in a hydride, a metal hydride compound. So these are examples of the exceptions. All right, I'm not going to give you too many exceptions, but it is important that you recognize that rule. So for an example, in a metal hydride, hydrogen will actually take on a -1 charge. Okay, and also kind of like a rule of thumb when we are assigning oxidation states, if it is an ionic compound, then their ionic charge will typically also equal their oxidation state. Okay, and one of the rules that we'll get to a little bit later, in a compound, if there's no charge written on the entire compound, then we know that we have to have their oxidation numbers equal 0. So if this hydrogen here, because it's in a metal hydride, is -1, then the sodium will be +1. It would just take on its ionic charge because these are ionic compounds. And then, for example, this one, if the hydrogen in this case is -1 and there's 2 of them here, then that will make the calcium to be +2, so that whole entire compound will equal 0, okay? But the main thing that I want you to know for rule number 2 is that hydrogen will be +1. Once again, these are the exceptions that I listed here to just show you what the exception would look like. All right, so now let's go on to rule number 3. Let's see, scroll this down. Okay, so rule number 3, the oxidation number of oxygen in a compound is always -2. So that is the rule that I want you to remember for oxygen. Oxygen will be -2. There is an exception if it is in a peroxide. Now, I typically won't give you an exception to the rule, but I just want to show you what the exception would look like because sometimes it might be on a homework question. So if it's in a peroxide such as H2O2 that's written here, oxygen will actually take on a -1 charge rather than a -2. So then if we do our math, once again, this whole compound has to equal 0. So 2 times -1, right, equals -2. Therefore, this hydrogen here is going to be +1. So that all of those will equal 0. Okay, rule number 4. The oxidation number of an uncombined element is going to be 0. So that means that it is all by itself. It is not combined with anything different. For example, your diatomic molecules would also fall under this rule. So here we have some examples. See, sodium all by itself, and there's also no charge written on sodium. So that would be a 0, okay? Same thing goes for iron. No charge is written on here. It's all by itself, not combined with anything, so that will be 0. This also goes for diatomic molecules. So this oxygen here will also be 0. Okay, so let's go on to the next rule, rule number 5. For a neutral compound, okay, so a neutral compound, the sum of the oxidation numbers in the compound must equal 0. Okay, must equal 0. So this is similar to what we would do if it was ionic, right? We would assign their ionic charges so that they will equal 0. And that also goes for these here. When we assign their numbers, they have to equal 0. Once again, if it's an ionic compound, they will take on their ionic charges. It would be the same for their oxidation states. All right, so barium and sulfur come together, so this whole thing has to equal 0. Okay, so then therefore it is ionic, so these will just take on their ionic charges. So barium is +2 because it's in group 2, and this whole thing has to equal 0. Therefore the sulfur is -2. Then we come across this next example here. It has a transition metal, so we have to work backwards. So we know that chloride is in group 7, so those halogens have a -1 charge, and if we do our math correctly, there's 3 of them, right? So that equals -3. So then this iron has to be +3 to equal 0. All right, the last rule here, let's go ahead and read it, but the actual example is on the next page. Okay, so this is the last one. So for a polyatomic ion, the sum of the oxidation numbers must equal the ionic charge of the ion. Okay, so if it has a charge on it, it's not going to equal 0. We're going to set it equal to the charge. So let's take a look at those examples. Okay, so these are all polyatomic ions. Notice here the charges are written on them. Okay, so then we're going to go through all of our rules. So here we have oxygen, right? So do you remember the rule for oxygen? Oxygen is always going to be -2. Okay, now to finish out this math and stuff, I mean, we could do the math in our head, but I also want to show you how you can set this up like in an algebraic expression if you'd like to do that. Some people like to write things out like that, and that's perfectly fine. Some people can just do this math in their head. Okay, so then we want this whole thing to equal -1. See how it has a -1 charge? Okay, so if we write out a mathematical equation, so we want it to equal -1. So there's 3 oxygens, and that has a charge of -2. So then that is a total of -6, right? And then, therefore, we're trying to find out what the nitrogen is going to be, and there's only 1 nitrogen. So then we can say nitrogen is X, right? So now, if we solve for X, we're going to do the opposite operation on both sides, right, to get our X value. So then, therefore, X plus -6, so that means you are going to minus -6 on both sides, right? So if you minus -6 on both sides, right, that becomes positive. So this equals 0 here. So therefore, X will equal +5. Okay, it's also really important for your oxidation numbers that you indicate if the number is positive or negative. Okay, so this ends up being positive 5. And you can do the math in your head too, right? So 3 times negative 2 is negative 6. So negative 6 plus what has to equal negative 1. So that's how the nitrogen becomes plus 5, right? 5, negative 6 equals negative 1. Okay, so we do the next one. So you should try these next ones by yourself. So let's check. So the rule for oxygen, once again, is oxygen is going to be negative 2. So let's try doing this one with just doing the math in our head. So 2 times negative 2 is negative 4, right? And it has to equal negative 1. So then what plus negative 4 equals negative 1. So therefore, this time, the nitrogen is going to be plus 3, right? 3 negative 4 equals negative 1. Notice here that this is an example showing you that in this compound here, NO3, nitrogen was plus 5, but in this example, nitrogen was plus 3. So some of them could have different or multiple oxidation states, okay, depending on what it's combined with. All right, so let's do the very last one. Once again, we know that we have a rule for oxygen, right? Oxygen is going to be negative 2. So let's do our math. Negative 2 times 4 is negative 8, and it has to equal negative 1. So therefore, the manganese is going to be plus 7. Okay? So 7 minus 8 equals negative 1. All right, so that is how you assign oxidation numbers. You have to know all of those rules. So the best way to remember the rules is to practice, okay? So just a summary of some of the, I guess, rules that stand out. Hydrogen is going to be plus 1. Oxygen is going to be negative 2. If it's not combined with anything, then it's 0. If the compound has no charge on it, you want all of the oxidation states to add up to equal 0. If it has a charge on it, then the numbers have to add up to that charge. Okay, so that's just a quick summary of all the main things you need to know in terms of assigning oxidation states. And we will practice more in class. But that is the foundation. Okay, you have to know how to assign your oxidation numbers. All right? Okay, so that's it for this lesson, and I will see you later. Bye.